Selamat sejahtera to Doctor. I am Cheng Singi from Group 7 and now we will start to present the solutions of our group assignment. First of all, before I start, we will go to the slide which represents the task allocation for each of group members. As shown in the slide, later on, each member will present their own part according to the order which is shown as below. This slide includes the content of our presentation, which we are going to present the question 1, 2, and 3, and the reference will be attached at the end of the presentation. So now, I will start with question 1, which will discuss the data plotting, initial state vector, and transition probability matrix. According to the question 1, we are asked to plot the historical data. Based on our discussion, we decided to choose the data from the year 2020 for the company of Hong Leong Bank Berhad, which is from 2 January 2020 to 31st December 2020. The figure 1 shows the graph of historical closing price of Hong Leong Bank Berhad. Next, I will show the derivation of 3-state transition probability matrix. There are 3 variables, which are U, D, and R, which represent the up state, down state, and remain states respectively. The U state is the state when the share price increased from the previous day. It consists of 101 number of observations from the total number of 247 trading days. Next, the D state is the state when the share price decreased from the previous day. It consists of 108 of number of observation. Lastly, for the state R, it is the state when the share price gets unchanged from the previous day. It consists of 38 of number of observations from the total number of 247 trading days. The table shown describes the number of observations for each state. Next, I will present the initial state vector, which is shown in the slide, where 0.4089, 0.4372, and 0.1539 gives the probability of the share price in state up, state down, and remain same respectively, while on the right hand side show the transition probability matrix that we obtain.
Hello doctor, my name is Poon Karman and we will move on to question 2, which consists of long-term behavior, expected number of visits to a state, and expected first reaching time from different states. For long-term behavior, we use this formula where P is raised to the power of T and P is our transition matrix. And this becomes the long-term probabilities T years from now. From our calculation, the Markov chain has achieved stability starting from T equals 6, with the second matrix shown in the slide. Therefore, we can make conclusion about the probability of the share price in the future, regardless of the initial states up, down, or remain the same, where for increasing is 0.4115, for decreasing is 0.4389, and for remain the same is 0.1496.
Hi, my name is Mohammed Sirajuddin, and for the expected number of visits to a particular state, we use the formula as can be seen on the left hand side of the slide, where I is the initial state and J is the destination state. With the transition probability matrix and steady state probabilities obtained from previous calculation, where the steady state probabilities are 0.4115, 0.4389, and 0.1496, to find the expected number of visits to a state J starting from state I and using the formula, we can obtain the equation on the right hand side. By using the equations that we obtained, we can get the final answer as shown in the matrix at the bottom right of the slide, where the number of expected visits to state U, which is MUU, is equals to 2.430 if the share price is currently in state U, and where MDD equals to 2.278 represents the expected number of visits to state D if the share price is currently in state D, and etc. Therefore, we can see the expected number of visits to any particular state using the matrix obtained.
Hello doctor, my name is Janice Lee Jiehui and now I will move on to the expected first reaching time of different states. To calculate it, we will use the transition probability matrix and the formula at the right hand side. First, we let Tj be the expected number of steps until the chain hits state U, D and R for the first time respectively. For the first case, if the chain hits state U at first, we will obtain the following equations. And the expected first reaching time to reach state U starting from state J is 4.091. For second case, The expected first reaching time to reach the state of D starting from state J is 3.8693. And lastly, for the third case, the expected first reaching time to reach the state of R starting from state J is 8.9423.
Hello doctor, my name is Lim Siu-jin and I will be presenting about types of Markov chain and limiting distribution. For types of Markov chain, we found that our Markov chain is irreducible where the state S has only a single communicating class, as it can go from any state to other states in a finite number of steps. Next, our Markov chain is also aperiodic since there exist self-transitions in the chain which are PUU equals to 0.4059, which is more than 0, PDD equals to 0.4112, more than 0, and PRR equals to 0.2895, more than 0. Next, to find the limiting distribution, we use the following formula. We take the initial state vector times t to the power of n as limit n approaches infinity. Then we found that our limiting distribution is 0.4115, 0.4389, and 0.1496.
Hello doctor, my name is Nabil Raj and we will now talk about the stationary distribution. By using the stationary property, we will get pi p. And to find the stationary distribution, we need to solve the equation pi p equals to pi. Finally, we will get the same answer as the limiting distribution, which is 0.4115, 0.4389, and 0.1496. This is because the chain is irreducible and aperiodic. We will now move on to the references. These are all our references, doctor. That is all from our Group 7, doctor. Thank you.